Okay, guys, good evening and welcome back to Electric Circuits. So, we were discussing a few properties of the capacitor, yes. And what was the last thing that we discussed? The fact that for a capacitor, the voltage cannot change suddenly or instantaneously. But please keep in mind that there can be exceptions to this point or to this fact. Okay, so what did we write previously? So if you look at the statement at the top, I said what? In general, voltage across the cap. Let me make it full screen. What is it? In general, voltage across the capacitor cannot change suddenly or instantaneously, because that sudden change in voltage across the cap, it requires what? An infinite current to flow through the cap. And in any real circuit, because always there will be some resistance present in the circuit, it is not possible to have infinite currents. So that's why the voltage across the cap also cannot change suddenly or instantaneously. Okay, but in some idealized circuits, like what? Like this circuit, where the wires connecting the various elements. So in this circuit, the assumption is what? That the wires connecting the various elements in the circuit, they do not have any resistance, and as such there is no resistor present in the circuit, no resistors, and also the wires have zero resistance. That means what? On the whole, there is no resistance at all in the circuit. If there is no resistance at all in the circuit, only in that case it is possible to have infinite currents in the circuit, due to which the voltage across the cap, it can actually change suddenly or instantaneously. Okay, so just to elaborate on this fact a little more. Okay, what is it? Voltage across the capacitor cannot change suddenly or instantaneously. This sudden or instantaneous change, it means what? The change occurs in zero time. Okay, now when I say t equal to what? 0 minus. When I say t equal to what? 0 minus. So all of you know the meaning of 0 minus. Just before t equal to 0. T equal to 0 minus, it means what? We are at just before t equal to 0. So if you have to assign a value for t equal to 0 minus, that will be 0 minus epsilon. So the value of the time at 0 minus, it is not 0. T equal to 0 is what? Exactly at t equal to 0. But I am saying what? T equal to 0 minus, which is just before t equal to 0. So the value of the time just before t equal to 0, it will be equal to what? Some 0 minus epsilon, where epsilon is what? It's a very small positive quantity which will tend to what? 0 and so on. So 0 minus epsilon is what? The value of t at 0 minus. Okay, and then when we write t equal to 0 plus, when we write t equal to what? 0 plus, t equal to 0 minus is what? Just before t equal to 0, and t equal to 0 plus is what? Just after t equal to 0. Just after t equal to 0, what is the value of t going to be? It will definitely not be 0, because it is what? Just after t equal to 0. It will be slightly greater than 0. 0 minus will be what? Slightly less than 0. 0 plus is what? Slightly greater than 0. So for slightly less than 0, we wrote the value of the time to be what? 0 minus epsilon. So obviously at t equal to 0 plus, the value of the time will be what? 0 plus epsilon, where again epsilon is what? A very small positive quantity. Okay, now let us say I show these two instants on the timeline. Okay, let this be the timeline, and on this timeline, let this be 0 minus, let this be 0 plus. So on the timeline, I have shown the two instants. One is what? 0 minus, the other one is what? 0 plus. See, if you have two instants, t1 and t2, let's say you have two arbitrary instants of time, t1 and t2. Now if I ask you, what is the amount of time between t1 and t2? What do you say? I have two instants, t1 and t2. I am asking, what is the length of the interval between t1 and t2? Will it not be t2 minus t1? Do you all agree with that? I have two instants, t1 and t2, and if I ask you what is the length of the time interval between t1 and t2, you should say it is what, t2 minus t1. Okay, in the same way, what is the length of the interval between 0 minus and 0 plus? That means from 0 minus to 0 plus, what is the length of the time interval? Okay. So between 0 minus and 0 plus, what is the length of the time interval? Now the 0 minus, it is like t1, and 0 plus, it is like t2. Yes, and delta t between t1 and t2 will be equal to what? t2 minus t1. Yes, it will be what? t2 minus t1. So 0 minus, it is like t1, and 0 plus, it is like t2. Now what is the value of t2? t2 is what? The value of t at 0 plus. t2 is what? The value of t at 0 plus. t1 is what? The value of t at 0 minus. Already we assigned the values for t at 0 minus and 0 plus. At 0 minus, what is the value of t? 0 minus epsilon, or simply minus epsilon. And at t equal to 0 plus, the value of t is what? 0 plus epsilon, or simply plus epsilon. So t2, is it not plus epsilon? So epsilon minus, and t1 is what? 0 minus. 0 minus, the value of t is what? Minus epsilon. So will it not be 2 epsilon? So what is this 2 epsilon? It is the length of the time interval between 0 minus and 0 plus. 2 epsilon is what? The value of the time interval between 0 minus and 0 plus. I hope it is clear. I mean, there is nothing in this. Okay, we have two instants, t1 and t2. What is the interval between t1 and t2? It is simply t2 minus t1, and t1 is what? 0 minus, t2 is what? 0 plus. So what is the length of the interval between 0 minus and 0 plus? It is 2 epsilon. But in the very beginning, I told you what? Epsilon, it's a very small positive quantity which will tend to what? 0. If epsilon tends to 0, even 2 epsilon, will it not tend to 0? That is the whole point of this discussion, that from 0 minus to 0 plus, what is the length of the time interval? It is almost 0. Understood? From 0 minus to 0 plus, what is the length of the interval? It is almost 0. Now, in a time interval of length 0, can voltage across the cap change? No. In 0 time, voltage across the cap in general cannot change. In 0 time, it means what? Suddenly, voltage across the cap does not change. That means voltage across the cap, will it not remain the same at both 0 minus and 0 plus? Voltage across the cap in general, because it cannot change suddenly or instantaneously, voltage across the cap in general will remain the same at 0 minus and 0 plus. Why it remains the same at 0 minus and 0 plus? Because the length of the interval between 0 minus and 0 plus is what? Almost 0. What is the length of the interval? Delta t from 0 minus to 0 plus is what? Almost 0, or it will tend to what? 0. So in a 0 interval, or in an interval of length 0, the voltage will not change. Okay, that means in general, the voltage across the cap, VC is what? Voltage across the cap at 0 minus, it will be equal to what? Voltage across the cap at 0. It will also be equal to what? Voltage across the cap at 0 plus. Because from 0 minus to 0, and also from 0 to 0 plus, and even from 0 minus to 0 plus, the length of the time interval is what? 0. In a 0 interval length, the voltage across the cap cannot change suddenly. Okay, it is clear. In general, voltage across the cap will remain the same both at 0 minus as well as 0 plus because from 0 minus to 0 plus, the length of the time interval is what? 0, and the voltage cannot change suddenly or in 0 time. So the voltage will remain the same at both 0 minus and 0 plus. So this is what? The implication of the fact that voltage across the cap, it cannot change suddenly or instantaneously. Okay, I hope this point is clear. Again, going back to basics, Let's say we have some two-terminal element. We have what? A two-terminal element. This element, it can be anything. This element, it can be anything, but it is what? A two-terminal element. Now across this two-terminal element, the voltage drop is what? V, and the current is what? I. So look at the direction of the current. Clearly it is flowing from plus to minus. Then in such a case, the power absorbed by the capacitor, sorry, not capacitor, by this element, it will be what? The voltage multiplied with current flowing from plus to minus. So PABS, it will be what? V into I. This is very basic thing that we already are quite familiar with. Now, if we take the capacitor, if we take the capacitor across which the voltage drop is what? VC, through which the current is what? IC. So look at the direction of the capacitor current. Clearly it is flowing from plus to minus. Now here also I is what? Flowing from plus to minus, and when we multiply V and I, we obtained the power absorbed by the element. In the same way, if you multiply this VC and IC, if you multiply VC and IC, won't you get the power absorbed by the capacitor? Yes. I mean, it's a very obvious thing. So P ABS, that is what? Power absorbed by the capacitor. Okay. Power absorbed by the capacitor. Okay. So what is this PABS? It is the power absorbed by the capacitor. Will it not be equal to VC into IC, voltage times current flowing from plus to minus? What is IC in terms of VC? What is IC in terms of VC? Current in terms of voltage. IC, the moment I say IC, you should say IC is what? C dVC by dt. So this is what? VC into IC is what? C dVC by dt. I mean, in place of IC, I just wrote C into dVC by dt, because that is what? Current in terms of the voltage across the capacitor. Okay. Now, what is the expression for d by dt of Vc square? What is the expression for d by dt of Vc square? Will it not be 2Vc and then dVc by dt? Yes or no? D by dt of x square is what? 2x times dx by dt. In the same way, d by dt of Vc square is what? 2Vc times dVc by dt. Now from here, Vc, from first let me write the right hand side. This 2 will go to the other side. So Vc times dVc by dt, is it not equal to d by dt of Vc square by 2? I hope all of you agree with this. What I did is to send this 2 to the other side, so that right hand side, what is left? Only Vc into dVc by dt is what left. Vc times dVc by dt is what? D by dt of Vc square by 2. D by dt of Vc square by 2. Now if you come back to this expression for the power absorbed by the capacitor, look at the expression Vc into C times dVc by dt. So if you take out C, then what is left? Vc into C dVc by dt. Vc into dVc by dt, is it not d by dt of Vc square by 2? So first let me write C, then we have what? Vc into dVc by dt. Vc into dVc by dt is what? D by dt of Vc square by 2. Again, the value of C, is it not a constant? C is what? Capacitance value. For a given capacitor, C is what? Constant. Because C is what? Constant, it will definitely go. I mean, it can be sent into the derivative. So this can be written as what? D by dt of half C Vc square. D by dt of half C Vc square. That's all. Now left hand side is what? Power absorbed by the capacitor. What is the meaning of power absorbed by the capacitor? Power is what? Rate of flow of energy, or rate at which work is what? Done, and so on. Yes, power is what? Rate at which work is done, or rate of flow of energy. Now power absorbed by the capacitor, is it not the rate at which energy is stored in the capacitor? Remember, capacitor, it can store energy. How will the capacitor store energy? Capacitor will store energy in the electric field between the two plates. Okay, see. So if this is what? The capacitor, across which the voltage drop is what? Vc. Then the top plate, is it not the positive plate, and the bottom plate, is it not the negative plate? Whenever there is a potential difference, there will be what? Electric field directed from high potential to low potential. I said this in the very beginning. Okay, whenever we have a potential difference, an electric field will be present from high potential to low potential. So for this capacitor, top plate is what? Positive, bottom plate is what? Negative. So between the two plates, from top plate to bottom plate, you are going to have this electric field, and some energy will be stored within this electric field between the two plates. Now coming back to the power absorbed thing, power absorbed is what? Rate at which energy is stored in the capacitor. Okay, now just some notation. Wc, from now onwards, Wc will represent what? Energy stored in the capacitor, because energy stored is what? Related to work done. Okay, so whatever work you do, that will be stored in the capacitor, and so on. Okay, so Wc is what? It is the energy stored in the cap. Wc is what? Energy stored in the cap. Now power absorbed is what? Rate at which energy is stored in the cap. Rate of flow of energy, or rate at which energy is stored in the cap. So PAVS, is it not d by dt of Wc? Yes or no? D by dt of Wc is what? Rate at which energy is stored in the capacitor, and that is equal to what? D by dt of half C Vc square. So d by dt and d by dt both will get cancelled out. So what is the expression for the energy stored in the capacitor? It is half into C into square of the voltage drop across the capacitor. That's all. There is something you already know, but this is how you get it. Okay, power absorbed is what? Voltage times current, and current is what? C times dVc by dt, and that can be expressed as what? D by dt of half C Vc square. And the meaning of power absorbed is what? Rate at which energy is stored in the capacitor. Because see, resistor will absorb energy. Yes or no? Resistor will absorb energy, but that energy will be dissipated in the form of heat and so on. But the capacitor will also absorb energy, but that energy won't be wasted or dissipated. It will be stored in the capacitor, and the same energy which is already stored in the capacitor can be given back to the circuit and so on. Okay, so d by dt of Wc is what? Equal to d by dt of half C Vc square. That means Wc of t, energy stored in the capacitor as a function of time, is equal to what? Half into C into Vc square of t. Wc of t is what? Half into C into Vc square of t. So if you know the voltage across the capacitor at any instant, then you can always find the energy stored in the capacitor at that instant. It is simply what? Half into C into square of the voltage across the capacitor at that instant. Half into C Vc square of t. I hope it is clear. Okay, so that's about the energy stored in the capacitor. Okay, so as far as I think, this is pretty much what you should know about the capacitor. So a couple of points before we move on to problem solving on capacitors. Number one, capacitor, it stores what? Charge. It not only stores charge, it also stores energy. Where does it store energy? It stores energy in the electric field between the two plates of the capacitor. Okay. And in general, for a parallel plate capacitor, both the plates will carry what? Equal and opposite charge. Plus Q on one plate, minus Q will be stored on the other plate. So one plate will be what? The positive plate, and the other plate will be what? The negative plate. And the fundamental relation for a capacitor is what? Q equal to CV. Q equal to what? CV. Q is what? The magnitude of the charge stored in the capacitor. And V is what? The voltage across the capacitor between the two plates of the capacitor. Okay. And from there, we get the relation between current and voltage. Yes, on I equal to what? C dV by dt. I equal to what? C dV by dt. And for any capacitor, there will be three possibilities. Either the voltage across the cap will remain constant or it can change. Okay. If the voltage across the cap remains constant, that means what? dVc by dt is 0. Rate of change of voltage will be 0 if the voltage remains constant. And if dVc by dt is what? 0, then the current through the cap will also be 0. So whenever current through the cap is what? 0, then the voltage across the cap will remain constant. It does not change. But the capacitor, it can also get charged or it can get discharged. Okay. Charging, it means what? Value of Vc, it will increase with time. Discharging, it means what? The value of Vc, it will decrease with time. And how do you decide if any capacitor is going to get charged or discharged? You just have to look at the direction of current. If a positive current flows into the plus terminal of the capacitor, if a positive current flows into the plus terminal of the capacitor, then the cap will get charged. But if a positive current flows out of the plus terminal of the capacitor, then the same cap will get discharged. Okay, so in this way, you can decide if the cap will get charged or discharged. Okay, and then what is the voltage in terms of current? What is the voltage in terms of current? Vc of t will be equal to what? Vc of 0, which is the initial voltage across the cap, plus 1 by C integral Ic dt from 0 to t. Yes or no? Vc of t is what? Vc of 0 plus 1 by C integral Ic of t dt from 0 to t. This is what? Voltage in terms of current. Current in terms of voltage is what? Ic equal to C dVc by dt. And then we looked at the two types of, or the two ways of connecting a number of capacitors. Okay, capacitors connected in series and also capacitors connected in parallel. And we also discussed capacitive voltage division. Okay, so what is that capacitive voltage division? When you have a number of capacitors connected in series across a voltage source, then obviously that voltage will get divided among the various capacitors, and the voltage across any capacitor is inversely proportional to the capacitance. Okay, and you can directly apply capacitive voltage division when the initial voltage is what? 0 for all the capacitors connected in series. Yes or no? We have extensively discussed about when to apply capacitive voltage division and when not to apply. So if the initial voltage is what? 0 for each and every capacitor, then we can directly apply that capacitive voltage division. But if the initial voltage is not 0 for any of the capacitors connected in series, then you should go by a slightly different approach, and you know what that approach is. So for capacitors connected in series, current will be same, and integration of current will give you what? The extra charge that is added to what? Every capacitor. So when you have capacitors connected in series, the same amount of extra charge will be added to what? Each and every capacitor. So in this way, we can find the change in voltage across each and every capacitor, and in the end you have to write what? KVL and so on. Okay, and when it comes to capacitors connected in parallel, again current division will take place, and the current through any capacitor is directly proportional to the capacitance. Okay, current through any capacitor directly proportional to the capacitance. Okay, and the last important fact is what? That the voltage across the capacitor in general, it cannot change suddenly or instantaneously. Okay, and because of this fact, in general, again, Vc at 0 minus will be same as what Vc at 0 plus, unless you have an impulse current flowing and so on. Unless you have an impulse current, the voltage across the cap will remain the same at 0 minus and 0 plus. But if the circuit does not contain any kind of resistance, then it is possible for the voltage to change suddenly or instantaneously, in which case Vc at 0 minus will be different from Vc at 0 plus. Okay, and finally we found the expression for the energy stored in the capacitor as a function of the voltage drop across the capacitor, and that energy stored in any capacitor is what denoted by Wc. Wc will stand for what? The energy stored in the capacitor. Okay, so Wc of t is what? Half into C into Vc square of t. So this is pretty much the summary of our entire discussion on the capacitor. Okay, so just to get familiar with the equations relating the current, voltage, etc., let us solve a few problems. Okay, so on the screen you can see the first question. So what is given in this question? We have a capacitor whose value of capacitance is what? 5 millifarad. So what is this 5 millifarad? It is the value of C. So C is what? 5 millifarad. You have to find IC. IC is what? Current through the capacitor from plus to minus for two different values of Vc. In the first case, Vc is what? Minus 20. In the first case, Vc is what? Minus 20 volts. Minus 20 volts, is it not a constant value of voltage? Yes or no? Minus 20 or plus 20 or plus 100 or minus 200. These are what? Constant values of voltage. So this is constant. If Vc is constant, what is the rate of change of Vc? If anything is what? Constant, rate of change will be what? 0. So dVc by dt, it is what? 0. If dVc by dt is 0, even IC is going to be 0, because IC is what? C dVc by dt. Vc constant, dVc by dt is what? 0. No current will flow through the capacitor, very obvious. Okay, and then look at the second case. Look at the B case. B case, the value of Vc is what? 2 times e power minus 5t. So in the B case, what kind of voltage we have across the capacitor? Is it not an exponentially decaying voltage? Do you all agree with that? Clearly, because of e power something, it is what? Exponentially varying with time, because it is what? E power minus 5t. E power minus 5t, it will exponentially decay with time. Okay, so the voltage across the cap in the B case, it is what? Exponentially decaying with time. Because it is what? Exponentially decaying, that means what? Voltage is decreasing. Is the cap getting charged or discharged? Is the cap getting, in the B case, please comment in the chat box, is the cap getting charged or discharged? Is what? Decreasing with time, yes or no? Vc, it is what? Decreasing with time. That means what? Cap is getting discharged. So can you just tell me the value of IC, would it be positive or negative? The value of IC, will it be, is it going to be positive or negative? Please comment in the chat box. Negative, yes. If IC is what? Positive, then positive current is what? Flowing into plus. If IC is what? Positive, then positive current is what? Flowing into plus. Positive current flowing into plus, cap will get charged, Vc should increase. But here, Vc is what? Decreasing, or cap is what? Getting discharged, for which current should flow out of plus. So the current flowing into plus will be what? Negative. So clearly, IC should be what? Negative. Anyway, let us find dVc by dt. What is dVc by dt? Differentiation of this thing with respect to time. Is it not minus 10 e power minus 5t? That's all. Now IC is what? C times dVc by dt. IC is what? C into dVc by dt. What is C? What is C? 5 millifarad. 5 milli is what? 5 into 10 power minus 3 times dVc by dt is what? Minus 10 e power minus 5t. That's all. So 5 into minus 10 is what? Minus 50. 10 power minus 3, let us write it as milli. 10 power minus 3 is what? Milli. So we will write the current in what? Milliamps. Okay. So 5 into minus 10 is what? Minus 50 e power minus 5t. Then we have 10 power minus 3. So the current is what? Minus 50 times e power minus 5t units milliamps. C times the rate of change of voltage across the cap, that is what? dVc by dt. Understood? Yes. So even in the second problem we have what? A capacitor. What is the value of the capacitance? It is 5 microfarad. What is the value of the capacitance? It is 5 microfarad. Vc is what? The voltage across the cap. Ic is what? The current through the cap. And then what waveform is given? What is this plot? It is the plot between the current and time. How the current varies with time. That plot is given. So given the current waveform, you have been asked to draw the voltage versus, you have been asked to draw the voltage waveform. If you are plotting current versus time, that resulting graph is called the current waveform. If you are plotting voltage versus time, the resulting graph is called as what? Voltage waveform. So given the current waveform, you have been asked to plot Vc versus t. So what is this plot? Vc versus t. It is nothing but the voltage waveform. Okay. It is what? The voltage waveform. Current waveform is given. You should draw the voltage waveform. Please try to draw the voltage waveform. I will also draw it. Then you just verify if you have drawn the same waveform or not. And please keep in mind that the current is what? In milliamps. Current is in milliamps. And the time, it is in milliseconds. Okay, so here IC, it is what? In the units of milliamps. Okay, let me write it here. So this is what? Milliamps. And time, it is in milliseconds. Please keep that in mind. Okay. Okay, I am assuming you have drawn some waveform. What waveform? Vc versus t. You see, up to t equal to 0. Up to t equal to 0, what is the value of the current flowing through the cap? Up to t equal to 0, what is the current flowing through the cap? Up to t equal to 0, current is what? 0. Yes. You see the starting point is what? IC equal to C times dVc by dt. And from here we can write dVc by dt is what? IC by C. And from here we can write dVc equal to what? 1 by C times IC times dt. dVc is what? 1 by C times IC times dt. Okay. And now we should integrate on both the sides. Okay. Let us do the integration from minus infinity up to t. Minus infinity up to t. Because right hand side the integration is what? Being done from minus infinity up to t. Left hand side the limits of the integral will be what? Vc at minus infinity up to Vc at t. I hope everything is clear so far. There is the same old thing that we have already written before in our discussion on capacitor. Okay. Now integration of dVc. Integration of dVc is what? Simply Vc. And then if you plug in the limits, won't you get Vc of t minus Vc of minus infinity? Yes. So left hand side you will get Vc of t minus Vc of minus infinity equal to what? 1 by c integral minus infinity to t ic of t dt. I hope it is clear up to this point. What is the value of Vc at minus infinity? Minus infinity, t equal to minus infinity is what? Like the beginning of time, like the beginning of universe. At the beginning of time or at t equal to minus infinity, everything will be what? 0. So here also we can safely assume that Vc of minus infinity, it is what? 0. If Vc of minus infinity is what? 0, then the equation, does it not become Vc of t equal to what? 1 by c integral minus infinity up to t ic of t dt? Yes or no? Vc of t will be equal to what? 1 by c integral minus infinity up to t ic of t dt. So how do you understand this equation? Left hand side is what? Vc of t. That means voltage across the cap at any instant. Voltage across the cap at any instant will be equal to what? 1 by c times. What is the meaning of integration? Integration means what? Finding area under the waveform or under the function. In this case, we are integrating what? IC. That means voltage across the cap at any instant will be equal to what? Area under the current waveform from minus infinity up to that instant multiplied with 1 by c. Yes, I will state it again. In fact, you can make a note. You can make a note. All of you write this equation. First write this equation. Vc of t is equal to what? 1 by c times integral minus infinity to t Vc of t, sorry, Ic of t dt. And this equation, it means what? It means what? Now note it down, okay? Voltage across the capacitor. Voltage across the capacitor at any instant, voltage across the capacitor at any instant is equal to area under the current waveform, area under the current waveform from t equal to minus infinity. Voltage across the capacitor at any instant is equal to what? Area under the current waveform, area under the current waveform from t equal to minus infinity up to that instant. Yes, area under the current waveform from t equal to minus infinity up to that instant. And this area, that means what? The value of the integral should be multiplied with 1 by c. So you just continue that statement. Voltage across the capacitor at any instant is equal to what? Area under the current waveform from minus infinity up to that instant multiplied with 1 by c, where c is what? The value of the capacitance, okay? That means, for example, let's say you want to find Vc at t equal to 1 second. If you want to find Vc at t equal to 1 second, then you should find the area under the current waveform from minus infinity up to 1 second. Then multiply that area under the current waveform from minus infinity up to 1 second with 1 by c. Let's say you want to find the voltage across the cap at 100 seconds. You want to find voltage across the cap at t equal to what? 100 seconds. If you want to find voltage across the cap at 100 seconds, then again find the area under the current waveform from minus infinity up to 100 seconds. From minus infinity up to 100 seconds, multiply that area under the current waveform with 1 by c. Understood, right? So this is how one can easily find the voltage across the capacitor at any instant. Now tell me, what is the area under the current waveform up to 0? Up to t equal to 0. That means from minus infinity up to t equal to 0, what is the area under the current waveform? Please type in the chat box. 0. What is the area under the current waveform? From minus infinity up to 0, it is 0. Area under the current waveform 0, that means what? The value of the integral is what? 0. If value of integral is 0, even the voltage across the cap will be what? 0. That means up to t equal to 0, the voltage across the cap will be 0, because it should be obvious. What is the value of Vc at minus infinity? It is 0. At the very beginning of time, the voltage across the cap is what? 0. Okay. But from t equal to minus infinity up to t equal to 0, did any current flow through the cap? From t equal to minus infinity up to t equal to 0, did any current flow through the cap? No current flowed through the cap, because the value of the current is what? 0. If current does not flow through the cap, will the voltage change? No. Voltage across the cap will change, will either increase or decrease only if some current flows through the cap. But if the current does not flow through the cap, then the voltage will remain constant. Already at the beginning the voltage is what? 0, because Vc at minus infinity is what? 0. So even up to t equal to 0, the voltage across the cap will remain what? 0, because no current is flowing through the cap up to t equal to what? 0. I hope it is clear. Okay. So what is it? Vc versus t. So up to t equal to 0, the voltage across the cap, it is what? 0. Up to t equal to 0, voltage across the cap, it is what? 0. Okay. I hope it is clear up to this point. Okay. Then you look at this interval. You look at this interval between what? 0 and 2 milliseconds. Look at the interval between 0 and 2 milliseconds. Current is flowing or not flowing? Current is flowing. How much current? How much current? 20 milliamps is flowing. In the interval between 0 and 2 milliseconds, a positive current of 20 milliamps is flowing. Number one, current, is it not constant? Current is what? Constant. And equal to what? 20 milliamps. In the interval between 0 and 2 milliseconds, the current is what? Constant and equal to what? 20 milliamps. Will the cap get charged or discharged? Please comment in the chat box. In this interval between 0 and 2 milliseconds, is the capacitor going to get charged or discharged? Charged. Because what is the direction of IC? IC is what? Flowing from plus to minus, and IC is what? Positive. That means we have a positive current flowing from plus to minus. If you have a positive current flowing from plus to minus, definitely the cap will get charged. Cap getting charged, it means what? Vc will increase with time. Now the question is, how will Vc increase with time? How will Vc increase with time? Will it increase linearly or non-linearly? Please comment in the chat box. How will Vc increase? Definitely, as you all agreed, in between 0 and 2 milliseconds, cap will get charged. Now Vc will increase. Will Vc increase linearly like a straight line, or will it increase non-linearly like some parabola or some exponential? Linearly. Very good. Why? Because the rate of change is what? Constant. Why rate of change is constant? Because current is what? Constant. Okay. Look at this. Look at this. 0 less than t less than 2 milliseconds. 0 less than t less than 2 milliseconds. That means what? We are talking about this interval. In this interval, IC is what? Constant. You know, dVc by dt is what? IC by C. dVc by dt is what? IC by C. And here in this interval, IC is what? Constant. C is also constant. So IC by C is also what? Going to be constant. Now what is the meaning of dVc by dt? What is the meaning of dVc by dt? Okay, one meaning is what? Rate of change. But more importantly, for the waveform, dVc by dt is what? Slope. dVc by dt is what? Slope. Very good. dVc by dt is what? Slope. So this means slope is what? Constant. Constant and positive. Slope is what? Constant and positive. A straight line will have what? A constant slope. And because the slope is what? Positive, in between 0 and 2 milliseconds, the voltage across the cap, it will linearly increase. It will linearly increase. Okay. So up to 2 milliseconds, Vc will linearly increase because the slope is what? Constant. Why the slope is constant? Because the current through the cap is what? Constant. Extremely important point. What about after t equal to 2 milliseconds? After t equal to 2 milliseconds, will the cap get charged or discharged, or will the voltage across the cap remain constant? Again, please type in the chat box, after 2 milliseconds, is the cap going to get charged or discharged, or neither charging nor discharging? I mean, the voltage remains constant. Vc will remain constant, because beyond t equal to what, 2 milliseconds, the current through the cap is what, 0. If the current is what, 0, then dVc by dt becomes what, 0. dVc by dt 0, it means what, rate of change of voltage across the cap, it is what, 0. Voltage remains constant. Very good. So after t equal to what, 2 milliseconds, again the voltage across the cap, it remains constant. That's all. There is the voltage waveform. Up to t equal to 0, no current, so even the voltage across the cap will remain at 0. But between 0 and 2 milliseconds, a positive current is flowing, and because the current is what, constant, the cap will get linearly charged, or the voltage across the cap will linearly increase with time. As long as current flows, cap will keep getting charged. But beyond t equal to what, 2 milliseconds, again the current, it becomes what, 0. Again, you know, when the current becomes 0, it is the voltage drop that becomes constant, not 0. Current 0 does not mean voltage drop is 0. Voltage becomes what, constant. It is the rate of change of voltage that becomes what, 0. Okay. Now the question is, what is the value of voltage to which the cap will get charged to at t equal to what, 2 milliseconds? Okay. I mean, it is quite simple. Vc at t equal to 2 milliseconds. Just make use of this formula. Okay. So in this equation, you just have to substitute what, t equal to 2 milliseconds, then you will get the value of the voltage across the cap at 2 milliseconds. 1 by C. What is C? What is C? 5 microfarad. So 1 by 5 microfarad is what? 1 by 5 into 10 power minus 6. And then integrate the current from minus infinity up to 2 milliseconds. That means what? You should find the area under the current waveform from minus infinity up to 2 milliseconds. What is the area under the current waveform from minus infinity up to 0? What is the area under the current waveform from minus infinity up to 0? Current value is 0, area is also what? 0. 0, very good. But what is the area from 0 to 2? Area under the current waveform from 0 to 2, is it not just the area of this box? What is the area of this box? Height into width. Height into width. What is the height? Height is what? 20 milliamps. Okay. So I am just directly writing area under the current waveform from minus infinity up to 2 milliseconds, and that is equal to what? Area of this box alone, and area of any box is what? Height into width. What is the height? 20 milliamps, which is 20 into 10 power minus 3, because it is what? 20 milli. And then height into width. What is the width? Duration, which is what? 2 milliseconds, right? 0 to 2, it is what? 2 milliseconds. Again, 2 milli is what? 2 into 10 power minus 3. Now the point is what? 10 power minus 6, 10 power minus 3, 10 power minus 3. Everything will get cancelled. What is 20 by 5? 4. 4 into 2 is what? 8. So this value, it is what? 8 volts. I hope you also got the same value. That's all. So between 0 and 2 milliseconds, the voltage across the cap, it will linearly increase from 0 to 8 volts. Thereafter, because the current through the cap is what? 0, voltage across the cap remains at 8. So just to say everything in one line, up to t equal to 0, voltage across the cap is what? 0. Between 0 and 2 milliseconds, voltage across the cap will linearly increase, and at t equal to 2 milliseconds, voltage across the cap becomes what? 8. Thereafter, Vc remains at 8. That's all. I hope it is clear as to how we drew the voltage waveform. Sir, can you please how we conclude? You see, Sainath, please listen. See, up to t equal to 0, what is the current flowing through the cap? 0. If no current flows through the cap, then the voltage across the cap does not change. Remember, the value of voltage across the cap at t equal to minus infinity is how much? It is voltage across the cap at t equal to minus infinity is what? 0. Yes, Vc at minus infinity, it is always assumed to be 0. So up to t equal to 0, because no current is flowing through the cap will remain uncharged, or the voltage across the cap will remain at 0. And then between 0 and 2 milliseconds, some non-zero current is flowing through the cap, but the current is what? Constant. And equal to what? 20 milliamps. Okay. Now, are we not having a positive current flowing from plus to minus, or a positive current flowing into plus? Whenever you have a positive current flowing into plus, it means what? Cap will get charged. Then we use the same fundamental equation. dVc by dt is what? IC divided by C. Now in this interval 0 to 2 milliseconds, because IC is what? Constant. C anyway is what? Constant. IC by C is also what? Constant. IC by C constant, it means what? dVc by dt is what? Constant. And because IC is what? Positive, even dVc by dt is what? Constant and positive. What is the meaning of dVc by dt? It is slope. So slope of the voltage waveform, it is what? Positive and constant. So will it not linearly increase? Slope positive and constant, it is a straight line which will linearly increase. Slope negative and constant, it will linearly decrease. Okay. So as long as current is flowing through the cap will continue to get charged. Vc will continue to linearly increase. But here the current does not flow forever. Current flows only up to what? 2 milliseconds. That is why only between 0 and 2 milliseconds you see Vc will linearly increase. And beyond t equal to what? 2 milliseconds. Beyond t equal to what? 2 milliseconds. What is the value of beyond t equal to 2 milliseconds? What is the value of the current? Current becomes 0. Again, when the current becomes 0, it is the rate of change of voltage across the cap that becomes what? 0. So rate of change of anything becomes 0. That means what? That thing is remaining constant. That does not change with time. So already at t equal to what? 2 milliseconds, Vc has become what? 8. So beyond t equal to what? 2 milliseconds, Vc remains at 8. I hope it is clear to all. Okay. Okay, look at this thing. Once again we have a capacitor. Whose value of capacitance is what? 100 picofarad. Okay. So here the value of C is what? 100 picofarad. Pico is what? 10 power minus 12, right? Pico is what? 10 power minus 12. That means 100 into 10 power minus 12 farad, which is 10 power minus 10 farad. That is what the value of C. Okay. And then you should plot IC versus T. What is given for the capacitor? Voltage waveform is given. In the previous problem, for the capacitor, the current waveform, it was given. This time for the same capacitor, the voltage waveform is given. So given the voltage waveform, you should draw the current waveform. It is extremely straightforward. What is current in terms of voltage? C into dVc by dt. Okay, that's all. So you know IC is what? C dVc by dt. dVc by dt is what? Slope of the voltage waveform. Okay, so it's dVc by dt. It is what? dVc by dt, it is what? The slope of the voltage waveform. Okay, that's all. Voltage waveform is given. You can find the slope at any instant. Yes. What is the value of the slope of the voltage waveform up to t equal to 1? Remember, time, it is in units of what? Millisecond. And voltage, it is in what? Volts. Okay. Look at this. Minus infinity less than t less than 1 millisecond. What is the slope? What is the slope? Is it not 0, all of you? Because up to t equal to 1 millisecond, voltage, is it not constant? constant, slope is what? 0. Okay. M denotes what? Slope. Okay. By the way, M is what? The slope. Okay. If slope is 0, then even IC, is it not going to be 0? I mean, voltage drop constant, whether it is 0 or non-zero, as long as voltage is what? Constant, current will be 0. What about between 1 and 2 milliseconds? Second is what? 1 millisecond less than t less than 2 milliseconds. 1 millisecond less than t less than 2 milliseconds, it means what? In between 1 and 2 milliseconds, the slope, is it not positive? And also because it's a straight line, for a straight line the slope is what? Constant. So for this there will be some positive slope. Now what is that positive slope? For any straight line, slope is what? Delta y by delta x. Yes or no? So this is delta y and this is delta x. Now from 1 to 2 milliseconds, the value of Vc, is it not going from 0 volts to 2 volts? Is it not going from 0 volts to 2 volts? So what is the slope? Delta y by delta x. Change in voltage is what? 2 volts minus 0 divided by change in time is what? 2 milliseconds minus 1 millisecond. 2 millisecond minus 1 millisecond is what? 1 millisecond. So is it not 2 volts per millisecond? That's all. The slope is what? 2 volts per millisecond. If you know the slope, you can find the current as well, because IC is what? C times dVc by dt, and dVc by dt is what? Slope. What is the value of C? It is 10 power minus 10. 10 power minus 10 into dVc by dt, which is what? Slope, and it is 2 volts per millisecond. 2 volts per millisecond, is it not 2 by 10 power minus 3? Yes or no? 10 power minus 10 is what? The value of C. And then the slope, that is what? The value of dVc by dt is what? 2 divided by 10 power minus 3, because 2 volts per millisecond per milli is what? 10 power minus 3. So it is what? 2 divided by 10 power minus 3. That's all. 10 power minus 10 by 10 power minus 3 is how much? 10 power minus 7. So 2 into 10 power minus 7. What is 2 into 10 power minus 7? Is it not 200 nanoamps? Do you all agree with that? 2 into 10 power minus 7 can be written as what? 200 nanoamps. 200 nanoamps. So what is this 200 nanoamps? It is the current flowing through the capacitor in the interval between 1 millisecond and 2 milliseconds. Okay. And finally, what about for t greater than 2 milliseconds? Again, if you look at the voltage waveform, t greater than 2 milliseconds, the voltage, is it not constant? Yes or no? T greater than 2 milliseconds, voltage, it is what? Constant. At what value? 2 volts. Voltage constant, rate of change of voltage is what? 0. Current is also 0. So t greater than 2 milliseconds, Vc is what? Constant. Then slope is what? 0. Then IC is also what? 0. That's all. So up to 1 millisecond, the current is what? 0. And between 1 and 2 milliseconds, the current is what? 200 nanoamps. Again, after 2 milliseconds, the current is what? 0. We can just draw the current waveform IC versus t. So up to 1 millisecond, the current is what? 0. Up to 1 millisecond, the current is what? 0. Okay. And from 1 to 2 milliseconds, the current is what? Constant and equal to what? 200 nanoamps. It is what? 200 nanoamps. So this is what? 1 millisecond. This is what? 2 milliseconds. And beyond 2 milliseconds, again the current is what? 0. Okay. I mean, it is very simple, but I am sure you also must have drawn the same thing. So up to 1 millisecond the current is what, 0. Between 1 and 2 milliseconds the current is what, constant and equal to what, 200 nanoamps. And after 2 milliseconds again the current becomes what, 0. So given the voltage waveform, we were able to draw the current waveform. In the previous question, current waveform was given. From the current waveform, we drew the voltage waveform. How do we get the voltage waveform from the current waveform? By integrating the current waveform. When you find area under the current waveform and so on, then you will find the voltage across the capacitor at any instant. From there, we can draw the voltage waveform. Okay. Okay, look at this circuit. How many capacitors are there in this circuit? 3 capacitors, okay. 1 microfarad and 4 microfarad capacitors, both are in series. Voltage across 1 microfarad is what, V1. Voltage across 4 microfarad is what, V2. And also you have one more capacitor, that is what, the 2 microfarad capacitor. And Vs is what, the applied voltage across this capacitor network. And Vs of t is what, given, some 100 times e power minus 80t volts. Vs of t, that is the value of this voltage source, it is what, 100 e power minus 80t volts. What is also given, V1 of 0. V1 of 0 is what, initial voltage across the 1 microfarad capacitor, that is also given. V1 of 0 is what, 20 volts. Okay. So given the initial voltage across the 1 microfarad capacitor, the question is to find V2 of t for t greater than 0. The question is what, to find V2 of t for t greater than 0. Okay. Please try to find V2 of t for t greater than 0. Give it a try. Okay. Please look at the screen. 1 microfarad and 4 microfarad, are they not in series? I will say it again. 1 microfarad and 4 microfarad, they are in series. Yes or no? They are in series. Across what? A voltage source. So are we not having 2 capacitors in series across a voltage source? What takes place when you have 2 capacitors in series across a voltage source? Capacitive voltage division will take place. Can't we directly write the voltage across the 4 microfarad capacitor? Yes. Look at this. So V2 of t will be equal to what? What is that voltage that is getting divided between 1 microfarad and 4 microfarad? Is it not Vs? So first you write Vs into, see, in case of capacitive voltage division for 2 capacitors, the voltage across one capacitor will be directly proportional to what? The other capacitor. In this case, V2 is what? The drop across the 4 microfarad capacitor. Drop across 4 microfarad capacitor will be proportional to what? The other capacitor, which is 1 microfarad. So V2 of t will be equal to what? Vs into 4, not 4, I'm sorry. Vs into 1 microfarad, drop across 4 proportional to what? 1 divided by ఎందొత్తు
గేట్ నైట్ వచ్చింది కదా, గేటుకు నేను రాక గేటుకు తాళం చేయించిన, ఓపెన్ చేసుకుని ఫోన్ సార్ ఓపెన్ చేసుకుని తాళం ఆనే పెట్టాము, తాళం చేయి మరి లేదు కదా, తాళం చేయి
పోయిందా? తాళం
చేయి ఎక్కడ ఉంది, ఎవరో తింటారు. ఇలానే ఉంటుంది దానికి కూడా పచ్చది,
ఎక్కడేం లేదు.
రైట్.
Okay. So what is V2 of t? It is the voltage across the 4 microfarad capacitor. I am just using what? Voltage division or capacitive voltage division. Okay. So V2 of t will be equal to what? Vs into 1 microfarad divided by 1 microfarad plus 4 microfarad. Clear? Again, microfarad and microfarad will get cancelled. So is it not Vs into 1 by 5? Yes. Or simply Vs by 5. What is Vs by 5? Vs of t is what? 100 into e power minus 80t divided by 5. 100 by 5 is what? 20. Yes. So this will come out to be 20 e power minus 80t volts. Is it correct? Is it correct or there's something wrong in this approach? Please comment in the chat box. Can't we directly apply capacitive voltage division? Not correct. Why? Okay, everybody is saying it is not correct, which is correct. Now tell me why this approach is incorrect. Why is this approach incorrect? Why is this approach incorrect? Very good. Cap is initially uncharged. I told you what? When you have a number of capacitors connected in series, you can directly apply this capacitive voltage division only when all the capacitors are initially uncharged. But here it is already given that V1 of 0 is what? 20 volts. So initial voltage across the 1 microfarad capacitor, it is not 0, it is some 20 volts. That itself means what? The capacitive voltage division cannot be applied. So whatever we did, this is totally incorrect. Okay. So this is not the correct way to go about finding V2 of t. Okay. Can you tell me what is the initial voltage across the 4 microfarad capacitor? Please comment in the chat box. What is the initial voltage across the 4 microfarad capacitor? Initial voltage, it means what? Value of voltage at t equal to 0. Okay. So can you tell me what is V2 of 0? What is V2 of 0? What is V2 of 0? Okay, for the 1 microfarad capacitor, the initial voltage is what? 20. In the same way, I am asking what is the initial voltage across the 4 microfarad capacitor? Is it 0? All of you? What about others? Everybody thinks it is 0. We can't say. Okay. What about others? What is the initial voltage across the 4 microfarad capacitor? What is given in the equation? Initial voltage across the 1 microfarad cap is what given, and it is what? 20 volts. And now I am asking what is the initial voltage across the 4 microfarad capacitor? See, I told you what? It is not 0. Let me tell you, it is not 0. Initial voltage across 4 microfarad, that is what the value of V2 of 0, it is not 0. I told you what? Always in any circuit, 2 laws must be satisfied. Always in any circuit, 2 laws must be satisfied or obeyed. What are those 2 laws? Please comment in the chat box. What are the 2 laws that should always be obeyed in any circuit? What are the 2 laws that are always obeyed by any circuit? KCL and KVL. Yes, that means at any instant the voltage and currents in the circuit should be such that KCL and KVL are satisfied. Okay. Now look at the circuit, all of you. Is it not a loop? Yes, on the left hand side, is it not a loop? Let us write KVL around this loop at t equal to 0. Let us write KVL around the loop at t equal to 0. So what do you get when you write KVL around the loop? At least now can you tell me what is V2 of 0? Okay, now that I gave the hint, which is what to write KVL around the loop, around this loop at t equal to what, 0. Can you tell me what is V2 of 0? What is V2 of 0? 80. Very good. Understood, right? V2 of 0 is what, 80. Previously you said V2 is what, 0, which is incorrect. So what is the initial voltage across the 4 microfarad capacitor? It is 80 volts, and that is from KVL around the loop. Because if you write KVL around the loop, you will get what? Because we are writing KVL at what? T equal to 0. Vs of 0 will be equal to what? V1 of 0 plus V2 of 0. In the equation, Vs of t is given. What is Vs of t? 100 e power minus 80t. Substitute t equal to 0. What is e power 0? 1. So Vs of 0 is what? 100. V1 of 0 is what? 20. So 20 plus V2 of 0. So what is V2 of 0? Like you said, it is 80. Okay, so what is V2 of 0? It is 80. So initial voltage across the 4 microfarad capacitor, it is what? 80 volts. But the question is what? To find V2 of t, not V2 of 0. V2 as a function of time. Okay, but V2 of 0 is what? 80 volts. So at t equal to 0, the value of V2 is what? 80 volts. Okay. Now let us see what else can be done. Okay. You see, let the current in this branch be some I. Let the current in this branch be some I. Now look at this branch. This branch contains what? 1 microfarad in series with 4 microfarad, and this entire branch is connected across what? The voltage source. If you have 2 capacitors connected in series, can't you find the equivalent capacitance? Please tell me what is the equivalent capacitance of this branch. Please tell me what is the equivalent capacitance of this branch. Which branch? Only this branch. Okay. Only for this branch. What is C equivalent? How much? Okay, I mean, having capacitors in series is similar to what? Having resistors in parallel. Having capacitors in series is similar to what? Having resistors in parallel. C1 C2 by C1 plus C2. 1 into 4 divided by 1 plus 4, which is 4 by 5 microfarad. So C equivalent is what? 4 by 5 microfarad. Understood? Now what you can do is to replace this entire branch with a single capacitor whose value is what? 4 by 5 microfarad, and across that single capacitor, what is the voltage going to be? Vs. Okay, so it is like this. I'll just repeat myself. What am I going to do? I'll replace this branch with a single capacitor whose value is what? 4 by 5 microfarad. Okay. So this is what? 4 by 5 microfarad, and across this we have the same voltage source Vs, and let this current be I. So what is the voltage across the single capacitor? It is Vs. Okay. Now what is the current through the capacitor? Will it not be C times dVs by dt? Because Vc is what? Vs. Current through that single capacitor will be what? C times dVs by dt. Okay. Okay. So current is what? C dVs by dt. Now and C is what? 4 by 5 microfarad. Remember, C is what? 4 by 5 microfarad. Now if you look at if you go back to the original circuit, in this branch we have our two caps connected in series, 1 microfarad and the 4 microfarad capacitor. Okay, so let me draw the two capacitors. Okay, 1 microfarad, this is what? 4 microfarad. Voltage across 4 microfarad is what? V2. Voltage across 1 microfarad is what? V1. Now also the current in this branch, is it not same as this I? So this I is same as what? This I. Okay. Now what is the current through the 4 microfarad capacitor? Is it not the same I? So whatever current flows through the single equivalent capacitor, the same current will actually flow through what? Both the capacitors which are connected in series. That is what? The 1 microfarad as well as the 4 microfarad capacitors. Okay. That's all. We are almost there. Now this I am writing the current voltage relationship for the 4 microfarad capacitor. Okay. So I is equal to what? 4 microfarad times d V2 by dt. Do you all agree with that? I mean, I equal to what? C dVc by dt. For the 4 microfarad capacitor, the current is what? I itself, and I is equal to what? C multiplied by d by dt of voltage. So I is what? 4 microfarad into dV2 by dt. Okay. So from here, what is dV2 by dt? It is I divided by 4 microfarad. Is it clear up to this point? Nothing new. dV2 by dt is what? I divided by 4 microfarad. Okay. Now you come back to this thing. So C is what? I mean C into dVs by dt. What is dVs by dt? Remember, Vs is what? 100 into e power minus 80t. Okay. Vs is what? In the equation it is given as 100 into e power minus 80t. So what is dVs by dt? Differentiation of this thing with respect to time will be what? 100 into minus 80, which is minus 8000 times e power minus 80t. Clear, right? Vs is what? Given to be 100 e power minus 80t. Differentiate this with respect to time, you will get minus 8000 times e power minus 80t. Okay, that is what? dVs by dt. Now come back to this thing where dV2 by dt is what? I divided by 4 microfarad, and I is what? C dVs by dt. C dVs by dt. I'll just clear this off. Now in place of I, let me write this thing. In place of I, here let us write this thing. Okay, what is it? C into dVs by dt. But before that, C is what? 4 by 5 microfarad. What is this 4 by 5 microfarad? It is 0.8 microfarad. So I is equal to what? C into dVs by dt. First write the value of C, which is 0.8 microfarad, into C into dVs by dt. dVs by dt is what? This thing, minus 8000 and then e power minus 80t whole divided by the green color thing, which is what? 4 microfarad. That's all. Now this micro and micro will get cancelled. What is 0.8 by 4? What is 0.8 by 4? 0.8 by 4 is what? 1 by 5. What is 8000 by 5? See, from here, won't you get dV2 by dt is equal to 0.8 by 4 is what? 1 by 5 minus 8000 by 5. 8000 by 5 is what? I think 1600. 8000 by 5, it must be 1600. Okay, so minus 1600 e power minus 80t. That's all. There is what? The value of dV2 by dt. It is what? Minus 1600 e power minus 80t. Now send dt to the other side. From here, dV2 can be written as what? Minus 1600 e power minus 80t and then dt. Now what? You integrate on both the sides. You integrate on both the sides because the equation contains what? dV2, but our goal is what? To find V2 of t. Our goal is what? To find V2 of t. So when you do the integration, won't you get this thing? V2 of t will be equal to what? Let us integrate from 0 to t. Okay, let us do the integration from 0 to t. If you are integrating from 0 to t, what are the limits of the integral on the left hand side? Will there not be value of v2 at 0, that is what? V2 of 0 up to v2 of t. What is the integration of dv2? It is simply v2. Now you substitute the limits. Won't you get v2 of t minus v2 of 0 equal to what? Integration of this thing with respect to time from 0 to t. What is the integral of minus 1600 e power minus 80t? Integration of minus 1600 e power minus 80t will be what? The same thing divided by minus 80. Minus 1600 divided by minus 80, minus and minus will get cancelled. 1600 by 80 is what? 160 by 8, which is 20. Okay? Minus and minus will get cancelled. So is it not 20 times e power minus 80t from 0 to t? Now if you substitute the upper limit and the lower limit, if you substitute the upper limit and the lower limit, upper limit is what? Only this thing, right? 20 into e power minus 80t, and the lower limit value will be what? E power 0 is what? 1. 1 into 20, is it not 20? Yes. 20 times e power minus 80t minus 20. Left hand side is what? V2 of t minus V2 of 0. Now previously did we not find V2 of 0? V2 of 0 is what? 80. So here you write down 80. That's all. We are done. Now this minus 80 will go to the other side. Minus 80 on the other side, does it not become plus 80? And 80 minus 20 is what? 60. So now we have the final expression for V2 of t. First is what? This thing, which is 20 e power minus 80t. 20 e power minus 80t. Then 80 minus 20 is what? 60. That's all. V2 of t is what? 20 e power minus 80t plus 60. How do you verify if this is correct or not? Even to find equivalent capacitance, okay, see, equivalent capacitance of a series combination of capacitors does not depend on initial voltage across the cap. Yes or no? Equivalent capacitance has nothing to do with the initial voltage across the cap. Is it clear? Yes. But if you are finding the voltage across any capacitor at some instant, then the initial voltages, they will matter or they do make a difference. But if you are finding only the equivalent capacitance, that does not make any difference. Okay. Anyway, this is the final expression for V2 of t. It is what? 20 times e power minus 80t plus 60. If you substitute t equal to 0, if you put t equal to 0, what is e power 0? 1. 20 into 1 is what? 20. 20 plus 60 is what? 80. Already we know V2 of 0 is what? 80. So this expression, it satisfies the initial condition for the 4 microfarad capacitor. What is the initial voltage across the 4 microfarad capacitor? It is 80 volts. Even from this expression, we get the same value for the voltage across the cap, which is what? 80. Okay. I hope the solution is clear. But once the class is over, again you try to solve it by the same approach without looking at the solution. Okay. Then it will become more clear. Okay. Okay. Look at the next problem. So in this circuit, what elements are there? First you have a voltage source. Yes or no? So in this circuit, you can find what a voltage source whose value of voltage is what 100 sine 2 pi t. So is it not a sinusoidal voltage source? So this voltage source, it is what? A sinusoidal voltage source whose value is what? 100 sine 2 pi t volts. Okay. What is this? What is the peak value of the sinusoidal voltage? Vp sine omega t. Vp is what? 100. Okay. So it's 100 volts. It is what? Vp. So Vp is what? 100 volts. Okay. Anyway, across this voltage source, two elements are connected. First is what? A resistor whose resistance is what? 1 mega ohm. Second one is what? A capacitor whose value is what? 20 microfarad. So in this circuit, all elements are in parallel. Obviously, they'll have the same voltage. So we can say voltage across the resistor and also the voltage across the capacitor, both are equal to what? The applied voltage, that is what? Vs, which is 100 sine 2 pi t volts. Okay. Now answer the 4 questions related to this circuit. First part. What is the first part? Find maximum energy stored in the capacitor. Please answer. Please type in the chat box. Maximum energy is stored in the capacitor. When will maximum energy be stored in the capacitor? When the voltage across the cap is what? Maximum. Yes or no? Energy stored in the capacitor is given by what relation? Half into C into square of the voltage across the cap. So for the energy stored in the cap to be maximum, even the voltage across the cap should be what? Maximum. And what is the voltage across the cap? It is equal to what? Vs. And what is the maximum value of Vs? It is the peak value, which is what? 100. Okay. So A part, Vc max. Vc max is what? Maximum voltage across the cap. Is it not equal to the peak value of the applied voltage, which is 100 volts? That's all. Now Wc max. Wc max is what? Maximum energy stored in the capacitor. It will be equal to what? Half into C into Vc max whole square. So half into what is C? C is what? 20 microfarad, which is 20 into 10 power minus 6. And then Vc max square is what? 100 square, which is 10 power 4. 20 by 2 is what? 10. So it is what? 10 power minus 1, which is 0.1 joules. I mean, very simple question. That is the first part of the question. Find maximum energy stored in the capacitor, and the maximum energy stored in the capacitor is what? 0.1 joules. Okay, 0.1 joules. Now the second part is what? To find the power absorbed by the capacitor as a function of time. Okay, again, power absorbed by any capacitor or power absorbed by any element is what? Voltage times current flowing from plus to minus. Okay. So look at this. Let IC be the current flowing through the capacitor. So what is the expression for the current flowing through the capacitor? Always current is what? Given by C into dVc by dt. And here for the capacitor, the voltage across the cap is same as what? The applied sinusoidal voltage, that is what? Vs. Okay. So C dVc by dt is same as what? C times dVs by dt. C dVc by dt is same as what? C dVs by dt. Okay. That's all. You just have to differentiate, the voltage with respect to time. What is the derivative of 100 sine 2 pi t? What is the derivative of 100 sine 2 pi t? Is it not 100 into 2 pi into cos 2 pi t? Yes. Before that, let me write the value of C. What is the value of C? 20 microfarad, which is 20 into 10 power minus 6. And then dVs by dt is what? 100 into 2 pi. Yes or no? 100 into 2 pi. And then differentiation of sine is what? Cos 2 pi t. That's all. Now 20 into 100 is what? 2000. 1000 into 10 power minus 6 is what? 10 power minus 3. 10 power minus 3, we'll keep it aside. Then we have what? 2 into 2 pi, which is 4 pi. Okay. So it is this thing, 4 pi cos 2 pi t milliamps. I hope you agree with this. 4 pi cos 2 pi t milliamps. That is what? The current through the capacitor. 4 pi cos 2 pi t milliamps. But the question is what? To find the power absorbed by the capacitor. PABS is what? The power absorbed by the capacitor. Power absorbed by the capacitor is what? Voltage times current, which is VC into IC. What is VC? It is 100 sin 2 pi t. 100 sin 2 pi t into IC is what? 4 pi cos 2 pi t milliamps. Again, milli is what? 10 power minus 3, which is 4 pi into 10 power minus 3 into cos of 2 pi t. Okay. Again, 100 into 10 power minus 3 is what? 10 power minus 1. 4 pi into 10 power minus 1 is what? 0.4 pi. Yes or no? 0.4 pi into sin 2 pi t into cos 2 pi t. You know sin 2 theta. You know sin 2 theta is what? 2 sin theta cos theta. Yes or no? Sin of 2 theta is what? 2 sin theta cos theta. And here we have what? Sin 2 pi t into cos 2 pi t. It is similar to what? Sin theta into cos theta. Sin theta into cos theta. Will it not be equal to sin of 2 theta whole divided by 2? Because sin of 2 theta is what? 2 sin theta cos theta. Sin theta cos theta will be what? 1 by 2 times sin of 2 theta. In the same way, sin of 2 pi t into cos of 2 pi t can be written as what? Sin of 4 pi t divided by 2. Do you all agree with that? Sin theta into cos theta can be written as what? Sin of 2 theta. Theta is what? 2 pi t. 2 theta is what? 4 pi t. So sin of 4 pi t divided by 2. So 0.4 pi times sin of 4 pi t divided by 2. Again, 0.4 pi by 2 is what? 0.2 pi. So the final expression is what? 0.2 pi. And then sin of 4 pi t units watts. Always be conscious about the units. Okay, current it is in what? Milliamps. And power absorbed, power will always be in units of what? Watts. Okay. So what is the power absorbed by the capacitor? 0.2 pi sin 4 pi t watts. Okay. I hope the first two parts are clear. So in the first part we found the energy stored in the capacitor or maximum energy stored in the capacitor. In the second part we found what? The power absorbed by the capacitor as a function of time, and it turned out to be this thing, 0.2 pi times sin of 4 pi t. 0.2 pi times sin of 4 pi t watts. Okay. Let us now answer the C part. What is the C part? Energy dissipated by the resistor between t equal to 0 and t equal to 0.5 seconds. Okay. Well, before that, let us solve the D part. Let us solve the D part. All of you, please tell me the answer for the D part. D for dog or D for donkey. What is the answer for the D part? Please type in the chat box. 0, right? I mean, what is the D part? What is the D part? It is to find the energy stored in the capacitor at t equal to what? 0.5 seconds. What is the energy stored in the capacitor at t equal to what? 0.5 seconds. Energy stored in the capacitor at any instant is equal to what? Half into C into square of the voltage drop across the capacitor at that instant. Okay. You know, voltage across the cap is same as what? The applied sinusoidal voltage. What is VC at t equal to 0.5? Simply in this expression 100 sin 2 pi t, you substitute t equal to what? 0.5. If you put t equal to 0.5, 2 pi into 0.5, is it not pi? 2 pi into 0.5 is what? Pi. 100 sin pi. What is sin pi? Sin 180 degrees is what? 0. Sin 0, sin pi, sin 2 pi, all these are 0. So sin pi is what? 0. So what is the voltage across the cap at 0.5 seconds? It is 0. Voltage drop 0. half C Vc square will also be what? 0. So energy stored in the capacitor at t equal to 0.5, it is what? 0. It is 0. Now the only remaining part is what? Oh, sorry. Now the only remaining part is what? C part. Only remaining part is what? C part. What is that C part? Find the energy dissipated by the resistor between t equal to 0 and t equal to 0.5 seconds. Okay. So what is it? We have the 1 mega ohm resistor across which the voltage drop is what? Vs. And what is Vs? It is 100 sine. It is what? 100 sine 2 pi t volts. And what are you asked to find? Find energy dissipated by the 1 mega ohm resistor from t equal to 0 up to t equal to what? 0.5 seconds. How do you find energy? Is it not by integrating power? Power is what? Rate of flow of energy, or rate at which energy is what? Dissipated by the resistor. But if you want to find energy dissipated by the resistor over a particular interval, you should integrate the power over that interval. Okay, it is like this. You know, P is what? dE by dt. P is what? dE by dt. From here, dE can be written as what? P into dt. P is what? dE by dt, rate of flow of energy. So dE can be written as what? P dt. And then what? If you integrate on both the sides, integral dE is simply equal to what? E. Integral dE is what? Simply equal to P E. And E is equal to what? Integral P dt from T1 to T2. So now what is this? E. E is what? Energy dissipated between T1 and T2. Energy dissipated between T1 and T2 is simply equal to what? Integration of the power from T1 to T2 will give you what? Energy dissipated in the interval from T1 to T2, okay, or between T1 and T2. Now for the resistor, already the voltage is what? Known. If you know the voltage, can't you write the power dissipated by the resistor? Power dissipated by any resistor is what? V square divided by R. That's all. So what is the power dissipated by the 1 mega ohm resistor? It is what? Vs square divided by R. Is it not 10 power 4 sine square 2 pi t divided by R is what? 1 mega, which is 10 power 6. 10 power 4 by 10 power 6 is what? 10 power minus 2. And then we have sine square 2 pi t. Units, watts. That is the expression for the power dissipated by the resistor as a function of time. 10 power minus 2 times sine square 2 pi t. Look at the power dissipated by the resistor. Is it not always positive? Yes, because always resistor will dissipate or absorb power. 10 power minus 2 is what? Positive. Sine square. Sine can be what? Positive or negative. But sine square is always going to be positive. 10 power minus 2 is what? Positive. Sine square is also what? Positive. Positive into positive will always be positive. You know, resistor will always dissipate energy or power. Okay. Anyway, now to find the energy dissipated by the resistor from 0 to 0.5 seconds, you should integrate the power from 0 to 0.5 seconds. Okay. That's all. So E is equal to what? From integration of the power from 0 to 0.5. Okay. and this is same as what? Integration from 0 to 0.5. P is what? 10 power minus 2 times sine square 2 pi t and then dt. Here 10 power minus 2 is what? A constant. Constant will come out of the integral. Okay. What is the integration of sine square? See, sine square can be written as what? Sine square can be written as 1 minus, say, I hope you must be knowing this relation. Sine square x is same as what? 1 minus cos 2x by 2. Do you all agree with this? Sine square x is same as what? 1 minus cos 2x whole divided by 2. And we have what? Sine square 2 pi t. Okay. That means sine square 2 pi t. In place of x, we just have what? 2 pi t. So sine square 2 pi t is same as what? 1 minus cos of 4 pi t whole divided by 2. I hope all of you agree with this. So sine square 2 pi t can be written as what? 1 minus cos of 4 pi t divided by 2. And we are doing what? We are integrating sine square 2 pi t from 0 to 0.5. Okay, and this is same as what? Integrating, in place of sine square 2 pi t, let us write that thing, which is 1 minus cos of 4 pi t whole divided by 2 and then dt. Now this 1 minus cos 4 pi t divided by 2 can be written as what? 1 by 2. This can be written as what? Integration of integration from 0 to 0.5. 1 by 2 minus cos of 4 pi t by 2, and this integration is what? With respect to time. Okay. What is integration of 1 by 2 with respect to time? 1 by 2 is what? Constant. Integration of dt is what? Simply t. So this is equal to what? T by 2. 1 by 2 dt integration is what? T by 2. Then we have to integrate the other term, that is what? Cos 4 pi t by 2 with respect to time. Okay. Integration of cos 4 pi t by 2 with respect to time. What is the integration of cos 4 pi t by 2? Will it not be sine 4 pi t divided by 4 into 2, which is what? 8. You can just convince yourself. So integration of this is what? Sine 4 pi t divided by 8. I mean, if you differentiate this, you should get back this thing. If you differentiate sine of 4 pi t divided by 8, in fact not 8, it must be 8 pi. Correct, right? If you differentiate sine of 4 pi t divided by 8 pi, remember 8 pi is what? Constant. What is the derivative of sine 4 pi t? 4 pi into cos 4 pi t. Now 4 pi by 8 pi is what? 1 by 2. You also have 1 by 2 here. And then we have cos 4 pi t. This should be understood. Okay. So for the first term 1 by 2, the integration is what? T by 2. And for the second term the integration is what? This thing, minus sine of 4 pi t divided by 8 pi. And then you should substitute the limits. What are the limits? 0 to 0.5. If you substitute the limits, what do you get? So in place of t, first you put the upper limit. If you put the upper limit, t by 2 is what? 0.5 by 2, which is 0.5 by 2 is what? 0.25, right? 0.5 by 2 is what? 0.25. And then you put t equal to 0 in second term, not 0, t equal to 0.5. If you put t equal to 0.5, 4 pi into 0.5 is what? 2 pi. Sine 2 pi is what? 0. Okay. So 0.25 minus 0. So what is this 0.25 minus 0? It is the value of this expression when you put in when you substitute the upper limit, minus the value of the expression when you substitute the lower limit. What is the value of this entire expression when you put t equal to 0? If you put t equal to 0, that is what the lower limit. T by 2 is what? 0. Even sine 0 is what? 0. So is it not 0 minus 0? So minus of 0 minus 0. So 0.25 minus 0 minus of 0 minus 0. This entire thing is what? 0.25. So what is this 0.25? 0.25 is what? The value of this integral. Integration of sine square 2 pi t with respect to time from 0 to 0.5. Its value is what? 0.25. Now let us go back to the earlier slide. So we are finding what? The energy dissipated by the resistor from 0 to 0.5 seconds, and it is equal to what? It is equal to what? Look at this. Let me bring out 10 power minus 2, and then we have what? Integration from 0 to 0.5 sine square 2 pi t dt. What is the value of this? Integration from 0 to 0.5 sine square 2 pi t dt. Integration from 0 to 0.5 sine square 2 pi t dt. Its value is what? 0.25. Yes. So this value, it is what? 0.25. That's all. Now 10 power minus 2. What is it? 10 power minus 2 into 0.25. Is it not same as 2.5 into 10 power minus 3? Remember, this entire expression will give you what? Energy dissipated. So 2.5 into 10 power minus 3, what? Joules, or this can be written as what? 2.5 millijoules. Did anyone get the same value? So when you go through the integration and so on, 2.5 millijoules, very good. Understood, right? Again, I did not do anything great here. I already know the voltage across the resistor. If you know the voltage across any resistor, you can find the power dissipated by the same resistor. Once you know the power dissipated by the resistor, to find the energy dissipated by the resistor in any interval, you should integrate the power in that same interval. In the equation, we have been asked to find energy dissipated by the resistor from 0 to 0.5 seconds. So all I did is to integrate the power dissipated by the resistor from 0 to 0.5 seconds, and in the end we got a value of what? 2.5 millijoules. I hope this is clear. So this completes our discussion on capacitor. Okay, so tomorrow we will get started with the energy, the other energy storage element, which is what? The inductor. Okay, and then we'll move on to what? First order circuits. So I'll see you in the next session. Okay.